Hi, welcome to Post Scholars, where we enhance learning through innovative methods. You have an opportunity to learn with Post Scholars now. Like, comment, and share.
Hi Scholar, you can call me Assassin. Welcome to Post Scholars YouTube channel. This video is categorized under the series Study to Show Yourself Approved for Jamb Mathematics. It will also be useful to you if you are in the senior secondary school or high school and preparing for any mathematics exam. By God's grace, I will try as much as possible to communicate this video tutorial or lesson very well so that you understand every bit of it. In this video, we shall be considering the topic Introduction to Number Base. If you are conversant with your Jamb mathematics syllabus, you would notice that the first topic in the syllabus is number base under the first section, number and numeration. So, after this video tutorial, students should be able to 1. Explain to others what number base in mathematics is all about. 2. Know all types of number system. 3. Understand the application of number base in real life. 4. Understand the application of number base by computer and the digital system. Remember, this is the second video in the playlist, Number Base. Do well to check other videos in the playlist so that your understanding of the curriculum topic, number base, will be solid. I want to assure you that if you follow me through all the videos, you will be very, very solid in any mathematics exam, either your NECO, WAEC, or Jamb, and any other kind. So, without any further ado, let's get started. Now, imagine you are counting objects, fingers, money, or even apples. The way we count and represent number follow a system, and that system is called a number base. Now, what is number base? A number base is simply the way numbers are written and organized. It tells us how many unique digits are used before we start repeating with a new place value. The important keyword in the definition of number base are unique digits, repetition, and what? Place value. The most common system we use every day is the decimal system. And this system is also known as what? Base 10. Are you following me? In this system, we count using 10 digits. And what are the digits? They are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Once we reach 9, the next number is 10. You can see? Because we have reached the highest point, which is 9. There is no other symbol in the base 10, right? You can use. So the highest is 9. So once we get to 9, you carry over and it becomes what? 10. You see, this 10 now has a new place value, unlike this particular 0. This 10 now has units and what? 10. Alright, you can think of a number base like a counting system. Different number base use different set of digits. This leads us to the subtopic types of number system. Types of number system. The first type we have is base 10. Base 10. It's also known as decimal. And the base 10 uses digits from 0 to 9. When you reach 9, you carry over back to what? 10. Same thing, or similarly, we have the base 2 as a type of number system. And the base 2 is also known as binary. Now, the base 2 system uses only 0 and 1. You cannot see any other digit aside from 0 and 1. Similarly, once the digit reaches, as you are counting, once the digit reaches 1, the next value will be what? 10. Right? Another type of number system is base 8, also known as octal. Base 8 uses 0 and what? 7. Any other digit is not allowed in base 8. Right? So when the number reaches 7, it carries over and becomes 10 in the next value. The next number system is base 16, also known as hexadecimal. Base 16 uses 0 and 9, or 0 to 9 rather, and added to it is your letter A to F. So this is how a base 16 number actually look like, or counting in base 16, this is how it looks like. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So this is how your base 16 is. Like when you are counting in base 16, this is the format. Now, take note that base 10 or binary is the normal number we use daily. We count in base 10 normally by default. If you want to count your teeth, it's in base 10. If you want to count the number of let's say apples on a tree, we use the base 10 system. So in the world we live in right now, we count based on what? 10, based on the base 10 system, right? Because the highest value we use is what? Is 9. Now next, binary or base 2. This one is used by computers and digital system. Binary and base 2 system is used in computers and digital system. Next, base 8 or octal. This one is used by in some computing application actually. The base 8 system is used in some computing application. Now next, base 16. Your base 16 is used in computer programming. Those of you that will study computer science and go deeper into computer programming, you would understand this better. But nevertheless, I will try my best to explain what base 16 is in computer programming. Okay, what exactly is number base? This is a big question. What exactly is number base? A number base is the foundation of a numbering system which determines how numbers are represented and counted using a specific set of digits. The base of a number system tells us how many unique digits are used before we start repeating with a new place value. If a number base takes the form x base y, your x here represents the number in digits and your y here represents the base, right? You see, the base of this number, right, tells us how many unique digits are used before we start repeating with a new place value. Take for example, I transform this one to 5, let's say 6 base 8. Right? So this number based system is telling us that we have to use 8 digits. Right? Once we have gotten to the 8th digit, we carry over, right, to the next place value. Just like how in our normal decimal system base 10, after 9 comes what? Comes 10. Okay, let us consider this subtopic, understanding number base, with examples. We'll consider the first one, base 10, right? Base 10. And your base 10 is also known as decimal. Your decimal system. Right? Now, this kind of number system, base 10, is the system we use daily in counting. Now, base 10 uses what? It uses 10 digits. What are the digits? They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? After 9, the next number is 10. This time, we move to the next place value. Each of these place value are units, right? Now, since we have exhausted the number, we move to the next place value here. So it becomes 10, next becomes 11, 12, 13, 14, 15, 16, 17, 18, 19. What will be the next number? You can guess right. It's 20. The unit has reached its peak, which is 9. So it becomes what? 10. But look at the 10 value here. It's just 1. So you added 1 to it to become what? 2. It has not exhausted its own because it's still less than your base, which is 9. So the counting goes on and on and on. Let's say, for example, we end here at 29. Tell me what will be the next value? It will be what? 30. How do we get 30? For the unit version, we have exhausted, we have reached the peak, which is 9. So it becomes 0. Then we add 1 to this one. It becomes what? 3. So it goes on and on and on and on like that. Next, let's consider base 2. Your base 2 is also known as what? Your binary system. Right? Your base 2 is used by computers. The digits allowed in base 2 are only 2 digits, which are 0 and 1. After 1, we move to the next place value. So 2 in decimal is written as what? 10. So let's actually count in base 2. Let's see how it looks like. 0, 1. You see, the next number is supposed to be 2, but we won't write 2. It becomes what? 1, 0. Right? So if you add 1 again to this 1, 0, it becomes what? 1, 1. If you add 1 to this 1, 1, it becomes what? Now look at this one. When you add 1 to this one, it becomes 2, but you can't write 2. So you write what? 0. Then the other one, you push it to this one. That's plus what? Plus 1. So 1 plus 1 gives 2, but you can't write 2. So makes what? This makes it what? 1, 0, 0. Right? So when you add 1 to 1, 0, 0, what do you have? You have 1, 0, 1. When you add 1 to 1, 0, 1, what do you have? Plus 1. This one becomes 2, but you can't write 2. So you write 0. The 1, you push it to the next place value. This one becomes what? 2. 1 rather. 1 plus 0 is 1. Then the last digit is what? 1. So this is how you keep adding and you keep progressing. Next is the base 8. Base 8, which is also known as what? Octal. Also known as octal. Now, base 8 is used in computing. It is used in computing. Only 8 digits are allowed, and these digits are 0, 1, 2, 3, 4, 5, 6, 7. Okay, that's all. 7. Right? The next number after 7 is 10. Right? So let's count in base 8 and see how it looks like. 0, 1, 2, 3, 4, 5, 6, 7. Can you say 8? No, the next will be what? 10. Then, okay, let me write it underneath. 1, 0, right? So what will be the next number? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. We have not exhausted it. 1, 6, 17. Pause, because we have reached the peak for base 8. So the next one become what? 20. How does it become 20? Because this 7 here becomes 10, right? So you write the 0, then you add 1 to the next place value, which becomes what? 2. Do you see how it is? Then next become what? 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7, right? The next become what? 30. How do we arrive at 30? How do you arrive at 30? 7 is already the highest, so it becomes 0 here, and it adds 1 to the next place value, which becomes what? 3. So it goes on and on similarly too. The next place value also is base 16. Base 16. I think this should be the fourth one. Are we counting it? 1, 2. Oh, we didn't count this one. This one is supposed to be number 3. Sorry, this one is supposed to be number 3. Then 4. The fourth one is what now? Hexadecimal. Also known as what? Base 16. Right? This type of number system is used in computing or is used in programming and web color. The digits in base 16 are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, and F. Yes, so that's how we count in base 16. So when you get to F, the next number becomes what? 10. Do you see the beauty? So it goes on and on and on like that. All right, let us consider some key points about number bases. Key points about number bases. First, a number base defines how many digits are used before carrying over, right? Number of digits. That's the first key point. The number of digits determines when it will be carried over. Number of digits. For example, for base 2, right? When you count 0, 1, the next number is supposed to be 2, but you add on to what? 10. So the next key point is that place values are determined by powers of the base. Place values are determined by powers of the base. Let's look at base 10, for example, like 2 and 5, base 10, right? The power of this base is just what? 10 raised to power 0, while the power of this 2 is what? 10 raised to power what? 2. So take note that place values are determined by the power of the base. Next, different bases are used for different application. For example, your base 2 is used for computer. Your base 2 is used for computer. Your base 16 is used for programming, right? And base 8 is used for certain computing function. We said this one is used for computer. This one is used for what? For programming. Don't worry, as you keep watching the video, I will expose you to how they are being used. And this one is used for computing, certain computing function. Computing function. Right? So counting in different base. Let's count 10. Let's count up to 10 using decimal base 10 and binary base 2. I want you guys to see something. Okay, so here we have decimal, which is also known as base 10, and here we have binary, which is also known as what? Base 2. So now let's count. For base 10, we are supposed to have how many digits? 10 digits, right? So let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because the next number will be what? 10. So let's now count for binary. For binary, remember we are working with base 2. So we have 0. The next number will be what? 1. The next number is supposed to be 2, but we don't write 2. It becomes 1, 0. Right? If you add 1 to 1, 0, you have what? 1, 1. If you add 1 to 1, 1, you have what? That should be 1, 0, 0. Right? How do we get that? If you add 1 to this one, it becomes 2, but you can't write 2, so you write 0. Then you carry over the 1 to this place. Then 1 plus 1 is what? 2, but you can't write 2 similarly. Then you write your what? 10. So I believe you understand how I'm doing it. Next one becomes what? 101. Yes. Next becomes 110. Next become 111. Next become 1000. Next become, that should be 1001. So we have counted up to 10 in base 10 and in base 2. If you want to add further, let's add one more. For base 10, after 9 you have 10, right? Then for base 2, after 1001 you have 1010. Now notice that in binary base 2 we only use 0 and 1. I've told you severally, we only use 0 and 1. When we reach 2 in decimal, it becomes 10. In binary, because we carry over when we run out of digits, just like we do inserting in decimal after 9. Now, we can also begin to ask ourselves, why are number base important? This is a good question. Why are number base important? The first importance we can see is 1, for everyday counting. Everyday counting, right? Because if you want to count the number of let's say you want to count the number of shirts in your wardrobe, you actually use a number system. If you want to count the number of vehicles on the road, you have to use a number system to count it. You get? So the second importance is the fact that it is useful in computer and technology. Number base is useful in computer and technology, right? Because computer use base 2, which is binary, to process data. I'm going to expose you to that as we continue in the video. So next, it's also useful in digital display. Number base is useful in digital displays and color. Have you ever seen something like this? Hash FF0000. Have you ever seen something like that? Don't worry. We shall look into it as the video continues. To further explore the importance of number base, let us consider this subtopic: application of number base by computer and digital system. Imagine a simple light bulb. Let me sketch a light bulb. Do something like this, right? Right, then I think add something like this, then a string, Consider a light bulb. Now, it can only be in two states. Light bulb can only be in two states. On or what? Or off. And we use 1 for on and what? 0 for off. Now, think of a computer as a machine that only understands on and off. Just like the light bulb. Since computers use tiny electrical signal, they cannot understand human language or number directly. Instead, they use a special way of counting called binary, right? Binary, which is also known as what? Base 2. Now, this consists of only two numbers, as we have said earlier on, 1 and 0. It does not support any other numbers. Let's consider how binary works in computer. Let's consider this. Just like we use base 10 decimal for counting 0, 1, 2, up to 9. Like I said earlier, computer counts and process information using base 2 binary, which has only two numbers, 0 and 1. Each 0 or 1 in binary is called a bit. Each of these 0 and 1 is called what? A bit. And this is short form for what? For binary digits. A computer stores and processes information using these bits, arranging them in groups to represent letters, number, pictures, sound, and even video. What does that mean? It means that if the computer wants to store let's say a video now, it can store it as 101011101011101101, which will be unique and different from any other kind of video, right? So let's look at some example of counting in binary. Just like in normal counting, after 9 we move to 10 in base 10. In binary, after 1 we also move to what? 10. So I think we have considered that before, but let's just consider it again. If you have for base 10, if you have for base 10 and base 2, we have done this before, but let's refresh. For base 10 and base 2, let's just count up to 5. Let's count up to 5. 0, 1, 2, 3, 4, 5. Then in the base 2 version, it becomes what? 0, 1, 10, 11, 100. Sorry, not 100. 100, then 101. You see, in binary, 10, 10, right? 10, which is in base 2, is equals to what? 2 in base 10. Let's look at it. I said 10 in base 2. Look at it. Is equals to 2 in base 10. Similarly, 11 in base 2 is equals to what? 3 in base 10. Also, 100 in base 2 is equals to what? 4 in base 10. This means that when you see 5 on a computer, the computer does not store it as 5. Right? If you see 5 on your computer, the computer does not necessarily store it as 5, but it stores it as what? As 101. Do you see it? Like we have said before, that computer only understands ones and zeros. Even letters on a keyboard has a binary code. For example, letter A in your computer is stored as what? 01000001. Including letter B is stored as 01000010. So when you type words on your keyboard, the computer see them as a long string of zeros and what? And ones. Pictures in binary. A picture is made up of what? Tiny dots. These dots are known as what? Pixel. And each pixel has a color code stored in binary number. The more pixel a picture has, the clearer it looks, including sound. Sound and music in binary. When you play sound, the sound wave, right? The sound you have converted into what? Zeros and what? Ones. Zeros and one. Zeros and ones. Now, computers store these zeros and one, process them, and play them back as sound. One reason why computers use binary instead of decimal is the fact that electricity has two states. Is that also your electricity? How many states does it have? It has two states. Either it is what? On, or it is what? Off. I know some of you might say it can have low current. No, neglect that, please. It's either it is on or what? It is off. Just like a light bulb can be on or off. So computers use tiny electric circuits that only recognize two states, as we have mentioned before. And that reason why computer uses binary instead of decimal is because of the fact that it is simple and reliable. Binary is easier for computer to understand and process compared to decimal number. Decimal number has how many digits? 10 different digits, unlike just binary, which has zeros and one. So in conclusion, even though we use words, pictures, and numbers every day, a computer only sees everything as what? Zeros. This is your takeaway. And one. And ones. It processes information using binary. We already know that it's in base 2, and converts it into what we see on the screen. Isn't that beautiful? So next time you use a phone, type a message, or watch a video, remember that deep inside, the computer is just working with millions of tiny zeros and ones. Next, we are going to consider application of base 8, which is known as Octal, in some computing. Imagine you work in a shop where you sell oranges, and instead of counting them one by one, you decide to count in group of 8. That means after 7, you don't say 8. You start a new group and write 10, which actually means 8 in your system. This is exactly how base 8 octal works. Instead of using 10 digits 0 to 9 like normal decimal numbers, octals only uses what? 8. 0, 1, 2, 3, 4, 5, 6, and what? 7. After 7, the next number becomes what? 10. Now, let's consider how computer use base 8. How computer use base 8. Computer don't naturally use octal, but they use binary. We have said that before, which consists of only zeros and ones. However, binary number can be very long and difficult to read. So octal is used to shorten them and make them easier for human to understand. Imagine storing a picture as 1011101010101011. You can see how cumbersome this can be. So let us consider how octal shorten binary codes. Let's look at this code, for example. 101110. Sincerely, this code is actually hard to read. So instead of writing this long binary number, we can convert it into octal for easier reading. So what we can do is group the binary digits into set of 3 from left to right. So this becomes 1. This becomes, okay, we are grouping it in 3. 101 110. Now let's analyze this. Right, so 101 is in what? Binary, the first set here, right? And the next set, which is what? 110. This one is also in what? Binary or base 2. Right? So we know that 101 in binary correspond to what? 5 in octal. And 110 in binary correspond to what? 6 in what? In octal. Therefore, we can say that 101, 110 in base 2, which is also binary. Let me use base 2. In base 2 is what? Is equals to what? 5, 6 in what? Octal. Isn't this beautiful? Therefore, we can see that octal is used in shortening long binary codes. Since 3 binary digits equal 1 octal digit, we have seen it. 3 binary digits equal just 1 octal digit. So we can say that octal is used to make binary numbers shorter and easier to read. This is very useful for computer programmers when writing machine level instruction. So octal is also used in the digital clock and old microprocessor. Next, we can consider why use octal instead of binary or decimal. Why do we actually want to use octal instead of binary and decimal? The major reason why we might like to use binary instead of octal, use octal instead of binary is because, one, it is easier to read, right? Easier to read. We just analyze this code where we have 101, 110, which finally became what? This 101, 110 finally became what? 56 in octal. You can see it for yourself. It's easier to read. So octal makes long binary numbers shorter and easier to understand. 2, it's also faster for programmer. It's faster for programmer. It helps programmers write and debug machine code more easily. Right? So in conclusion, even though we mainly use decimal base 10 in daily life and binary base 2 in computer, octal, which is in base 8, acts as a bridge to make binary number easier to manage. Yes, 10110. The bridge, which is octal, converts it to what? Just 5, 6. Right? So next time you see a 3-digit number in Linux permission, is a type of operating system, know that you are looking at an octal number, helping computer manage file efficiently. Next, let's consider how base 16, which is also known as hexadecimal, is used in computer programming. Let's look at this scenario. Imagine you are a shopkeeper who sells bag of rice. Normally, you count using 1, 2, 3, and so on. But if instead of counting up to 10, which is our normal base 10, you counted up to 16. That means instead of counting 0, 1, 2, 3, 4, to 9, which is our base 10, then you added some letters, which then becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E, and what? F. This is exactly how base 16, also known as hexadecimal, works. It uses 16 symbols instead of the normal words 10 digits. It uses 16 digits. Now, what is hexadecimal? Hexadecimal number system is a way of writing number using 16 symbols, as we can see right here. And if you observe these symbols very well, do note that A represents 10, B represents 11, C represents 12, D represents what? 13, E represents 14 and F represents what? 15. Once we reach F, which is 15 in this, once we reach F, which is 15 decimal, the next number is what? 10 in hexadecimal, which actually means 16 in decimal. So we can ask ourselves, why do computer uses hexadecimal? Right? Why do computers actually uses hexadecimals? Computers only understand binary. We have said that times without number, which is base 2, and it is made up of zeros and ones. However, binary numbers are too long and difficult for humans to read. So hexadecimal, which is base 16, is used to shorten long binary number, making them easier to read and work with in computer programming. I can say hexadecimals and octal, they work hand in hand in the sense that they help shorten binary codes. So how does hexadecimal work in computer? Hexadecimal uses 4 binary digits. If you remember, if you can recall rather, you will see that octal uses 3 binary digits, but hexadecimal uses 4 binary digits. Let us analyze a binary code which will be very hard to read. 110 110 110 110 1111100. You can see it's actually long to read. Now let's break this code into 4 sections. We have 1101 1011 1100. Right? Now let's analyze the code. 1101, which is in binary, is equals to D in hexadecimal. I know what D represents, right? D represents what? 13, right? D in hexadecimal. Similarly, 1011, which is in binary, form, represents what? B in hexadecimal. I will just shorten it in hexadecimal. And 1100, which is in binary also, represents what? The letter C in what? Hexadecimal. So you can see that 1101 1011 1100 is equals to what? DBC in what? In hexadecimal, right? So hexadecimals helps programmer work with binary number more easily. Imagine this code becoming this. That's very simple and easier to understand. Yeah, I remember I promised to explain how hexadecimals, which is base 16, is used in color. Now, have you ever seen color codes like this #FF5733 on a computer or website? This is basically what? Hexadecimal. Each color on a computer screen is made from a mix of red, green, and blue, which is called what? RGB system. Where R represents red, G represents green, and B represents blue. Now, in hexadecimal, colors are represented using 6 digits, right? For example, FFF, that's 6, is equals to what? White, right? Next, #000000 represents what? Black. Next, #FF000, I think, yes, 0, that should be 6, represents what? Pure red. So computers use hexadecimal to store and display colors efficiently. You see, this simply means that when computer wants to store the color white, it store it as this code, right? And when it wants to store pure rate also, it store it in the form of what? In the form of this code. So the question you can ask now is, why is hexadecimal important in computing? One, because it's shorting long binary code. We have seen that many times, and make them more readable. It's used in color representation. I just showed you now. This for black and this for white. It helps with memory addresses. It's used in machine codes, and it makes debugging and understanding computer data very easy. You see, hexadecimal is like a shortcut language for computers. Instead of dealing with long, complicated binary number, hexadecimals make them shorter, easier, and faster to work with. That's why programmers, web designers, and hardware engineers use hexadecimal daily in computing. We have come to the end of this video lesson. I hope the objectives has been met. Let's head on to the objectives. Remember, the objective was 1. Students should be able to explain to others what number base in mathematics is all about. I think we have covered that. Students should know the type of number system. We have covered that. Students should understand the application of number base in real life. We covered that. And students should also understand the application of number base by computer and the digital system. We also covered that. So in the next video, we shall consider the mathematical aspect of number base. You know, in this video, we just touched about the introductory part. And like I always tell students, if you don't understand the concept of something, it is very difficult for you to be able to solve problems involving that thing. Now I've exposed you to the concept of number base, how it came about and how it is being used. So I'll be seeing you in the next video where we shall start solving problems in number base. The next video will be conversion between bases. See you there and bye.